Hey Geometry! These are the last notes in our little mini unit on radicals. And our learning target today says I can divide expressions with radicals. And what we're going to be doing in most of these problems is usually called rationalizing the denominator. There are some things we need to keep in mind while we're doing this. Whenever you multiply a fraction by 1, it doesn't change its value. So if I multiply 3 over 3 times 1, that's still 3 over 3. I can multiply anything by 1 and it doesn't change. Another thing to keep in mind, any expression divided by itself is equal to 1. So like 3 divided by 3, that's equal to 1. X squared divided by x squared, that's still just 1. A square root multiplied by itself kind of cancels the square root. We saw that last time when we were multiplying radical 3 times radical 3. The answer is just 3. And last, and kind of most importantly here, a radical expression is not considered to be simplified if there are radicals in the denominator. So while we're working through these problems, the first thing we're going to do is use the quotient property if we can. So when we have a fraction underneath a square root, we can split it up into 2 separate square roots. And if we end up with a radical in our denominator, we will rationalize our denominator. So we do that by multiplying the numerator and the denominator by the radical that's in the denominator, and then we just simplify our radicals. So if we look at our first problem, I have 4 radical 2. I can't use my quotient property here because I don't have a whole fraction in my denominator. I just have a radical 2. So in order to rationalize that denominator, in order to simplify this, I am going to multiply by the square root of 2 over the square root of 2. The square root of 2 over the square root of 2 is really just 1. So I'm multiplying by 1, which doesn't change the value of my problem. When we multiply with fractions, we multiply straight across. So 4 times radical 2 is just 4 radical 2. And radical 2 times radical 2, I'm going to write it out this time, but then I'm not going to write it out ever again. So if I use my product property, that would be radical 2 times 2. So this would be 4 radical 2 over radical 4. And the square root of 4 is just 2. So we could skip all of these steps right here and just say that the square root of 2 times the square root of 2 is just plain normal 2. And now I'm going to simplify. I can divide 4 and 2. 4 divided by 2 is just 2. So my final answer is 2 radical 2. This is considered simplified. I don't have a radical in my denominator. And the radicand, the number inside my radical, cannot be broken down into any perfect squares. So, second one. This time we have 4 divided by the square root of 63. I have a radical in my denominator, so I'm going to rationalize my denominator by multiplying by the square root of 63 over the square root of 63. In the numerator, I'll end up with 4 square root 63. In the denominator, I just get 63. If I could divide 4 and 63, I would, but I can't. But I can simplify radical 63. So over here off to the side, I'm going to simplify the square root of 63. The square root of 63 can be written as the square root of 9 times the square root of 7. And the square root of 9 is just 3. So that's really 3 radical 7. So I'm going to rewrite my numerator as 4 times 3 radical 7. Oop, radical 7 instead of 4 radical 63. And this is still divided by 63. Now in my numerator, I can multiply my plain numbers. 4 times 3 is 12. So I get 12 radical 7 over 63. I can actually even take this one step further. 12 and 63 can both be divided by 3. So this would be 4 radical 7 over, oh, I should have grabbed a calculator. 63 divided by 3, oh, it's 21. 21. So that's my answer completely simplified. Okay, on number 3. This time I get to use my product property. I'm gonna break this up into 2 separate radicals. Sorry, not the product property, the quotient property. So I'm gonna break that up so that my numerator and denominator are each inside their own radical. I'm going to simplify. The square root of 4 is just 2. The square root of 5 I can't simplify. So now I need to rationalize my denominator. I'll multiply by the square root of 5 over the square root of 5. I end up with 2 radical 5 in my numerator. And the square root of 5 times the square root of 5 is just 5. This can't be simplified any further, so that would be my final answer. These problems don't get that much more complicated. The first step every time is going to be, well, maybe not every time, most times is going to be to multiply by whatever radical is in the denominator. In this case, I have 3 radical 5 in the denominator. So when I multiply, I'm multiplying both of these by the square root of 5. Now I need to use my product property here. So this would be 4 times the square root of 4 times the square root of 5 would be the square root of 20. And in the denominator, the square root of 5 and the square root of 5, the square roots kind of cancel each other out, and I end up with 3 times 5. So now I have 4 times the square root of 20 divided by 3 times 5 is 15. The square root of 20 can be simplified. So up over here, I'm going to give myself some space to simplify the square root of 20. That can be broken down to the square root of 4 times the square root of 5, which is just 2 times the square root of 5. So I'm going to rewrite this as 4 times 2 square root 5 divided by 15. 4 times 2 is 8, so this is 8 times the square root of 5 divided by 15. I can't simplify 8 over 15 anymore, so that's my final answer. Give the last one a try. Pause the video real quick and then come back and check your answer. For this last one, your final answer should be the square root of 6 divided by 6. So here are my steps to get there. I'm going to start by multiplying by my radical in my denominator. I multiply straight across. The square root of 3 times the square root of 2 is the square root of 6. 3 square root of 2 times the square root of 2. Well, square root of 2 times the square root of 2 is just 2. So that's really 3 times 2. So that's where we get the square root of 6 over 6. This looks like it could maybe be simplified further. And I think a lot of people's first inclination would be like, oh, 6 divided by 6 is just 1. So that's the square root of 1. But it doesn't work that way. The square root of 6 is being divided by 6. And the square root of 6 is like some decimal that I don't know. So this is as simplified as my answer can get.